the general solution of the given system. So here's the given system. Here the system written down, which is written down in the vector x prime. So let's call this matrix A. First you need to find A minus lambda I. So lambda I is lambda times the base matrix. That gives you this matrix. Then find the determinant of it. So I'm going to work across the row. So I have -1 minus lambda times to cover this column and this row. Cross multiply and then subtract them. 2 minus lambda times -1 minus lambda minus 3 minus 1 times 1 times -1 times -1 minus lambda minus 0, okay, and then plus 0, which is nothing. Okay, distribute this out, simplify it, and then set it equals 0. Then I found out that lambda equals -1, -2, and 3. So here's my eigenvalues. For each eigenvalue, I will get an eigenvector for it. So let's find out what those are. Let's take a look at the first case when lambda equals -1. Plug it into here. I got this matrix augmented with 0. Okay, normally you would reduce this down to a base matrix, but I knew that it will give me an infinite solution. So instead of going down to those matrices, I just work this out at this step. So look, for the first equation, I can see that k2 equals 0. Now let's use the second equation, k1 plus k3 equals 0. Why I didn't add 3k2? Because k2 is 0, so 3 times 0 is just 0. Just ignore it. So for k3, I got -k1. Choose k1 equals 1, then k3 equals -k1. You can choose whatever value for k1 as long as it's not 0. Alright, then my k1 vector k1 is 1, 0, -1. Now you are going to do the same thing for lambda equals -2. Plug it into here. That gives you this matrix augmented with 0. Okay, now let's see for look at the equation 3. You have 3k2 plus k3 equals 0. Solve for k3. I got -3k2. If I choose k2 equals 1, then that gives me k3 equals -3. Now let's use the first equation. I have k1 plus k2 equals 0. Solve for k1. I got -k2. Okay, and k2 is 1 as I chose it, so that also equals -1. Then my vector k2 is -1, 1, -3. Now you are going to repeat this process for one more time. For lambda equals 3, plug it into this matrix. That gives you this matrix augmented with 0. Again, do work smart, don't work hard. Try to avoid reducing it down to a base matrix. So I'm going to use the equation 3. I have 3k2 minus 4k3 equals 0. Solve for k3. I got 3 over 4k2. If I choose k2 equals 4, that gives me k3 equals 3. Now use the second equation. k1 minus k2 plus k3 equals 0. So k1 is equal to k2 minus k3. k2 is 4, k3 is 3, so that gives me 1 for k1. Then my vector k3 is 1 for 3. Right, now here's the most important step, which is writing your final solution. So because you have 3 distinct real eigenvalues, your final solution will be written in this form. Vector x equals c1 times k1, which is this, times e to the lambda 1t. Lambda 1 is -1, so you have e to the -t, plus c2 k2. Vector k2 is this, lambda 2 is -2, so times e to the -2t, plus c3 times k3, which is this, and then lambda 3 is 3, so you have e to the 3t. Okay, so that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.